Applying water from the exterior of a structure into a fire compartment requires a solid understanding of the impact of air entrainment and water distribution. As we begin to discuss the principles of exterior suppression, let's take a look at how the angle in which the stream is applied will affect the distribution. If we apply a hose stream perpendicular to a surface, the water will radiate in 360 degrees. We often picture that as a stream applied straight ahead towards a wall, but now let's imagine that stream applied to the ceiling surface of a compartment. The shallower the angle into the compartment, the more water that will be propelled forward towards whatever wall or obstruction is opposite the opening in which the water is being applied. This does not provide any surface cooling to the ceiling or walls that are nearest the ventilation opening where most of the burning is occurring. The steeper the angle into the compartment, the more water will radiate outwards in all directions, providing better surface coverage and better cooling. As the stream impacts the ceiling and the water radiates outwards, the momentum of the water carries it across the flat ceiling surface common in most residential structures. Once the water has coated the ceiling surface and reaches the side walls of the compartment, it falls down these surfaces in sheets. As the water reaches the floor, it now accumulates in pools in different areas depending on the obstructions that may or may not be present. This water application method nearly simultaneously coats all surfaces within a compartment and is extremely effective in suppression. During fire suppression, initially employing a steep stream to coat all interior surfaces simultaneously will rapidly reduce temperatures inside the fire compartment. The drop in temperatures causes the fire gases to contract, decreasing pressure, lowering temperatures, and improving survivability in adjoining spaces. Once the interior surfaces have been cooled and we have begun to knock down the fire, we must focus on getting water into the middle of the compartment to limit the likelihood of regrowth. If we are located on the same level as the fire, the nozzle can simply be inserted in the window and additional water can be applied to the remaining burning fuels. If we are located 1 or 2 floors below the fire, the hose stream can be deflected off of the window header or lintel to achieve additional distribution, followed by entry into the structure for final extinguishment. It's important to understand that utilizing a straight or solid stream during exterior water application is essential to ensure that we get the most amount of water into the compartment with the highest momentum, the largest droplet sizes, all while entraining the least amount of air. We must also ensure that the window opening is not occluded with the hose stream. An occluded vent will prevent the opening from serving as a low-pressure exhaust for the fire gases. Thus, the fire gases will be redirected to another low-pressure outlet within the structure. This is commonly referred to as pushing fire. Keeping the hose stream in a straight or solid pattern will limit the amount of air entrained and not disrupt the gases outside the fire compartment, whereas a fog stream employed into the opening will cause fire gases to move about the structure and potentially impact trapped victims and other firefighters operating on the interior.